Okay, new course, Wireless Design Fundamentals. What we will learn in this course, basically three parts. I categorize this course into. Wireless basics we will talk first. So not just Wi-Fi, but in general, all the terms, almost most common terms, let's say, in wireless terms and some terminologies, as you will see also in the course outline. So this is the sample video and also course introduction video, but there are many videos you can see in this course page. So lots of terms and terminologies. After that, we will start discussing type of wireless networks, different type of course, wireless LAN, wireless MAN, PAN, person area network, and wide area network. So we will touch on top of those wireless, different type of wireless networks, and we will discuss different wireless standards, 802.11, A, B, G, and ACAX. So there are new standards, of course, there, and speeds, coverage, range, this kind of differences, and we will discuss those. Also, of course, security. And after that, after we talked about the basics, we will discuss high-level architectures. Okay, so with the controller, without the controller, so different type of architecture based on if we have the controller or not. So autonomous architecture we will discuss first, control management and data plane perspective, and then understanding centralized and distributed and comparison of them. Classical architectural comparison we will make there. After that, little bit detail, of course, will start. Coverage design will be our first. So I took some notes basically also. So let's check in the coverage design. Yeah, we will check what is received signal, RSSI, SNR, background noise, signal to noise ratio, this kind of basic terms maybe, but these are important design consideration, especially when we want to have more coverage, more range, how many access points. So this will affect our choices in design. After that, we will discuss roaming. Of course, layer 2 as well as layer 3 roaming we will discuss. Mobile IP is important concept here. We need to understand, not only, of course, for the wireless LAN, but also for wireless WAN, wider network as well. Mobile IP should be understood. If you are traditional network engineer, you probably heard some mobile IP solution. Mobile IP is general and generic term for it, but also Lisp, locator and identity separation protocol, for example, or ILNP. These are other mobile IP or mobility solutions. So here in roaming, we will also discuss, of course, mobile IP as well. Channel design is another long topic will be. So we will have a look at two frequency spectrum. So we will look at 2.4 as well as 5 gigahertz frequency bands to 20, 40 different megahertz. So different channel design and their effect for the coverage as well in channel design. So there is an interference term, and we will learn this one in the wireless terms also in the beginning. But when we come to the channel design, we will of course discuss again, because co-channel interference and adjacent channel interference, these two interference or these two inefficiencies, let's say, it will affect the wireless design a lot. So we need to understand these things. And after that, of course, we need to understand what is single channel architecture, because mostly you are probably hearing from many places multi-channel architecture. Of course, in this course we will discuss as well, like use channel 6, use channel 13, or in 2.4 use these channels, and in 5 gigahertz use this. But what if we would have just single channel, and how would be the design? And then of course comparison between the single channel SCA and MCA architecture, multi-channel architecture. So we will compare them. Capacity design will be our last course topic in this year, but of course these are much more detailed than architecture. In general, when we compare also design and architecture, we say that, right? So architecture, when we say very high level, and design a little bit more low level, so HLD versus LLD concept. So that's why we are going to discuss some more details in the design section, WLAN design section. So in the capacity, of course, up to this point, we will be learning a lot. In the capacity also, we will be discussing, okay, those whatever we have learned until that point, how we can apply for the high density environment, very high density and ultra density, high density environment. So in this kind of environments, what should be our design consideration for more capacity, like for example warehouses or stadiums, how WLAN design should be basically there to cover entire area. Maybe there are thousands, if not tens of thousands of people. So what we should do in this kind of environments as well. And classical questions, of course, such as how many clients should be connected to per AP, how many APs per room. Like if you are again traditional network engineers, probably those very common questions such as how many ABR per area, or how many routers we should place in one, let's say, OSPF area, right? So similar, those frequent asked questions, if we think about it. So how many clients per access point, how many access points per room? And these are, of course, classical answer maybe depends, but we will be discussing those dependencies and we will justify our choices, of course, why we choose this design versus other design. Of course, every environment, different environment requires different design choices. That's why we will discuss those, not just classical business environment like every floor some amount of people, but maybe very, very large environments, as I said, like warehouses or stadiums, etc. And also we will discuss classical business environments or enterprise, corporate, those their headquarter buildings, let's say campus buildings, what should be the design in those environments as well. But there will be some technical discussions here, like band steering, load balancing, airtime consumption, and their effect into capacity. And of course, when we do some action in coverage, it will affect the capacity, or when we change the channel design, again it will affect the coverage and capacity, those kind of things. These are when we in design we call it butterfly effect. So when we change something here, let's say part A of the network, it will affect part B, part C. So that's why we need to understand the effect of our choices as well. And but when we understand behind the scenes how things work, definitely it will be very useful in our design and architectural choices. So without so much basically giving in the details about the agenda, I think if you think that this course agenda is for you, check the individual also video explanation, or the name of the videos, name of the lessons, let's say. If they are fine, then you can get this course. Let's start. Let's enjoy.